make sure that you have out your vocabulary sheet so that we can go over vocabulary. So, the very first vocabulary word we're going to talk about is a relation. It is a relationship between two sets or groups of number. A set of ordered pair is what we use in math to compare domain and range. And it's usually written like this. Oops. Like so. Okay. Then the domain is the set of all possible input values, or the x values, for a given function. So if I'm using this exact same thing, my domain for this would be all my x values. These are all my x values. So I would put them in numerical order, -2, 0, 4. Then I would look at my range, and it is the set of all possible output values, y values, for a given function. Okay? So I'm going to I'm going to underline them this side, these y's right here. So -12, 3, and 6 in numerical order. Okay. Then a relation can be represented in multiple ways. So you can have mapping, which is this very first one. And a lot of times you'll see it with 2 circles instead of 2 gray boxes, but it doesn't matter. The domain are the x values, the range the y values. Okay, sometimes you may hear this also be the input or the independent variable, and we'll talk about that later. And this being the output or the dependent, because it depends on the domain variable. Okay? We have a table, we have a graph, and we have an equation. So, what we're going to do is, we've been given this example, we're going to make a table. Remember, x's, y's. X's are the ones that come first. Then the y's. And there we have a table. Okay, then over here, we plot 2, 0, 0, 4, 1, 2, 3, 4, 1, 2, 3, -5. Oops, nope. I did the last, well, I could do that. I could have done that. I did the last point instead of, I was looking at the wrong one. There we go. And then we do a mapping. So I have the point 2, or the 3, -3. I have 0, 4, -5. So 2 goes to 0, 0 goes to 4, 3 goes to -5, and -3 goes to -5. And there we have mapping. So if I'm talking about the domain, I'm talking about the x values. So -3, 0, 2, and 3. Those are these right here. I put them in numerical order. The range are the y values. So -5, 0, and 4. Okay, so over here, we've been given a relation, and we need to write it as ordered pairs: -1, -5, 4, 7, -2, 3. Then write the domain. So those are the x values. So -2, -1, 4. My range are the y values. So -5, 3, 7. Okay, so over here I do my relation. Doesn't matter what order you put the ordered pairs in. So I'm just going to start left to right. So I would go over -2 and I go down 1, 2, 3, 4. So -2, -4. And then I go over 1, up 1, 2, 3. So -1, 3. And no space. 1, 2, 3, 4, 5. Is that right? 1, 2, 4, 5, up 1. So 5, 1. And doing it that way, you automatically put the domain in numerical order. So the x values, x, x, x. So -2, -1, 5. Then my range. I look at the y values. I put those in numeric order, -4, 0, 3. Next one. Ordered pairs. 1 goes to 5. 5 goes to -1. -6 goes to -1. So my domain, -6, 1, 5. My range, -1, 5. Does help when they write the words right up here. Okay, so, here's our independent and dependent variables. So, independent variable, the values in the domain correspond to the independent variable. It is usually the x value, and this value is subject to choice. Basically, what that's saying is you can choose what to plug in. You can choose to plug what goes in. Dependent variable, the value in the range corresponds to the dependent. It is usually the y value, and it depends on the x value. It depends on what you plug in for the x value in order to get the y value. So, as I look at this, part A says identify the independent and dependent variables. So I'm going to look at this. Okay, so as I look at this right here, time is usually our x value. So that means that this is our independent variable. Okay. This right here is our dependent variable. Okay. So what this is saying is as I increase my time, I get more and more and more text messages. Okay, this part right here, no new texts. This part right here, no new texts. But I should highlight this. Here, here, and here, I'm receiving text messages. That's what that means. Okay, so let's look at this. Identify the independent and dependent variables of each relation. Okay. Need a pencil again. The average price of tickets to an amusement park steadily increased over time. Okay, so again, most of the time what it's saying is I have time down here, and this is ticket price. So as time goes on, ticket prices go higher and higher. So time is going to be my independent, and ticket price is going to be my dependent. It depends on how much time that has gone by. So the air pressure inside a soccer ball decreases with time. Again, time is normally here. So it may have been inflated at this point, but over time, the ball decreases. So it depends on the time. The air pressure, that part goes here, is the dependent variable. Okay. So now let's talk about this next one. It says, after an airplane takes off, its altitude increases rapidly. Okay, so you go really fast when you take off. Well, you're going fast all the time, but you go off the ground, you go super high, super fast. Okay? Once it reaches the desired altitude, it continues to fly at that level for a short period of time. Then the altitude fluctuates slightly due to turbulence. So it may go up, it may go down. Finally, the altitude decreases quickly as the plane lands. Which graph represents this situation? Well, let's look at this. So we take off and we go high up in the air. Why am I doing blue instead of a highlighter? We go really fast. We decrease really fast. But if you look at the middle, that means I'm staying the same height the whole time. Well, it didn't say that. It said it fluctuates with turbulence. Okay? So I go up really high. I go down really fast. Did I fluctuate in between? I did fluctuate in between. I like this. This one says I take off, but it's a slow takeoff. I stay in the air and I never move, and I go back down, but slowly. Now, this one says that I go up fast, I come down fast, but this says I do a lot of up and down. But didn't it say up here fluctuates slightly due to turbulence? Okay, slightly. This one, letter D, that is not slightly. That's not slightly. Letter B does slightly. Okay. Kane notices the traffic congestion on his street on weekday mornings depends on the traffic of the day. He draws a graph that represents the relationship between the time of day and the volume of traffic congestion on his street on weekday morning. Analyze the orange segment, because we're analyzing the orange segment right here. Okay? So let's read through these very quickly. It says traffic congestion steadily increases at a very fast rate. So increase would be increases at a very fast rate. So wouldn't that be like that? Then traffic congestion is constant and very light. Traffic congestion is constant and very heavy. Okay, this would be, low on the graph. This would, same thing, but this would be higher up. And traffic congestion is decreasing at a steady rate. Okay? So if I look at this, I would have said this portion was A. I would have said this portion down here is B. I would have said this is C, and this is decreasing. So I would say that this is D. Okay. Scale. Now, you probably already know this, but scale. When graphing in the coordinate system, the scale of a graph refers to the distance or the intervals between tick marks on the x and y axes. Well, a lot of times we think of 1, 2, 3, 4. 1, 2, 3, 4. -1, -2, -3, -4. So these are going up and down by 1. Well, what if what we're talking about is talking about some number that's 800? Well, I'm not going to start on a graph that looks like this at 1, going up by 1s. Maybe instead of doing that, I don't know what that was, but okay. That was weird. Maybe this one says to go up by 400s. And maybe this goes up by 2s. Okay? So you have to decide what our interval is going to be on that. Okay? Oops. Don't like this new eraser. That was weird. Okay, so if I look, that is if I can make this smaller again. It says make sure that you know the scale of the graph. How much are x and y axes going up by? So let's look at this. If I'm just looking at my x values, my x coordinates, I'm just looking at them. What is the lowest number? The lowest number that I can see on there is a -36. The highest number that I see on there is 38. Okay, so now let's change the color. Now I'm going to look at my x values. My y values. So if I look at my y values, my lowest y value is -91. My highest value is 95. I just realized that half the word is on the other side. Okay, the x-axis should include values from -36, -36 to 38. But we kind of want more of a, should I say rounded number? No, I want it to go over the same amount. So I'm actually going to pick -40 to 40. Because those 40 and -40 are much easier to split in half. Okay? And then there's this thing that says notation, and we're going to go over that in just a second. The y-axis should include, I'm going to say, to keep it nice and rounded, I'm going to say -100 to 100. So the first part of this word is over here, interval notation. Okay? So interval, you know what? I can write it right here. Notation. Interval notation. So interval notation, I should have done it up here. Okay, so we're going to put it up here. You have it on your sheet already. So if I have interval notation, there are different ways to write it. you can either write it like the first or the second. The first one, this one includes the ending number, and I will talk about that more later. Okay. This is the lowest number. This is the highest. Okay. So if I'm looking at this interval right here, we're going from negative 40 to 40. So what's happening is I make this bracket, I write down the lowest number, then I write the highest number. Okay, so for this interval notation, I write the lowest number and the highest number. Okay, so all this tells me, this interval notation, is it tells me what do I want to say? Oh, I keep wanting to say scale, and it's not scale. What I'm going up from and what's going up and down. So, x-axis is going from negative 40 to positive 40. So that means this is negative 40. This is positive 40. How many lines are in between? 1, 2, 3, 4, 5, 6, 7, 8. Well, what's 40 divided by 8? That's 5. So we're going to go up by 5. 5, 10, 15, 20, 25, 30, 35. Now, you don't have to write all of the numbers. I just like to write the first couple. Then the next one, we said from negative 100 to 100. Well, let's see how many lines this has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 100 divided by 10 is 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And down here, I'm just going to write negative 10, negative 20. Okay, so the scale, we did by 5s for the x, we did by 10 for the y's. Now, we need to plot our points, okay? So our first point is 580. So I go to 5, I go over to 5 and up to 80. That's my first point. Then my next point, if I can pull it over, is negative 3648. Negative 36. Oops, I did not mean to do that. Okay, so negative 36, and I've forgotten the numbers already. Negative 3648. Okay, so it's not going to be perfect on here. So it's going to be negative 36 is going to be like here, and then I'm going to go up to 48, which is, about here. Does it have to be perfect? No. Okay, so our next one is going to be 25, negative 91. Okay, 25, negative 91. So 25 is here. So we're going down, and this is negative 90. So right below that, somewhere right here, is going to be 25, negative 91. 38, 95. 38 is going to be, about here. And 95 is going to be halfway in between. I should be writing this on here. 38, 95. This was 580. This one was 25, negative 91. And wasn't there another one? This is negative 38. Oh no, negative 36. 48, I think that's what it was. Negative 36, 48, okay. Negative 10, negative 50. Negative 10 is right here, negative 50. So this is negative 30, negative 40, negative 50. So this is negative 10, negative 50. And last but not least, 122. So 1 is probably about here, 22 about here. So this is the point 122. Awesome. Okay. So if I look at my x's, x, 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 x. So I have negative 10 is going to be my lowest. No. Yeah. Negative 10 is my lowest and 16 is my highest. Y, my lowest is negative 27 and my highest is 32. And we were supposed to write this in interval notation. Okay. What scale would you use? Well, I would probably go up by 2s here and maybe go up by 3s. I don't know. Actually, I want to undo this real quick. This is what it goes by. Oops. I don't want... If I want to do intervals and keep them the same, I should do this. So 16, so maybe negative 20 to positive 20. And maybe do this one, negative 40 to 40. And then I would probably do this by 2s and do this by 4s. That looks better to me. Now, could I have done it the other way? Sure. Could I have done it the other way? Not a problem. So, I have a study tip right here. And it says, when choosing an appropriate origin, you are still using the point 0, 0 as the origin, but are changing what it represents. And some of you are going to go, what? Okay. Before you say that, we're going to look over here at years. Do you see how it starts at 2005? Okay. 2005 is our very first year. So instead of writing 2005, 2006, like so, what we would do is we would say that 2005 is our 0 value. This would be our 1, 2, 3, 5, 6, 7, 8, 9, 10. Okay? So, weather. The table shows the snowfall in January for Boston. Let the X represent the year. Sorry. I couldn't remember what it said. Let Y represent total snowfall in inches. Okay, so once we do that, now, all sorts of alarms and what have you. This is going to be the year since 2005. I want to be better at my explanation because we're not going to be using the year 2005, 2006, 2007. We need to incorporate this into what the X's are representing. So origin is going to be year 2005 and 0 inches of snowfall. Okay, so my interval notation for this for the number of years, where did we start? We started with 0. We have to go up to 10. Well, how many of these lines do we have? 1, 2, 3, 4, 6, 7, 8, 9, 10. Look at that. It goes from 0 to 10. Now, interval notation down below, well, we need to know what the highest number is. So the highest number is 43. Okay, so we know it's going to start at 0. And what does it go through? Oh, I'm going to put years down here since 2005. So that's going to be starting at 0. And I'm going to do, did I really just do that? 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. I did just do that. I counted the wrong side for years. 7, 9, 10, 11, 12. I apologize for that. I do not know what I was doing. Snowfall. Okay, total snowfall I should put. And this is going to be in inches. That was 10. The highest number is 43. So could we go up to 50 and go up by 5s here? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So my interval notation would be from 0 to 50. And then what is the scale? This is the y-axis. I should have done 1s for the x-axis. Okay, so now we plot our points. So 2005 is 43, so that's up here. Maybe I'll make that a little bit bigger. 2006, 8.10, so 8.10, somewhere in here. Then 2007 is 1. And then 8.3. And 20, oops, that didn't come out. 23.7. Why isn't it working? There we go. And then 13, 20. And 38, 30. And then 6.8. And then 5. That was a nice one. 2180. Or 34. There we go. Okay. So we're going to come down here. And it says social media. The average number of posts per day on social media site each year is given in the table. Interpret the meaning of the axis, the scale, and the origin. Okay? What does the x-axis represent? So right here, years since 2008. Y, the average posts per day. And notice how it says that it's in the millions. So it's not just 50, but it's 50 million. How much does each tick mark on the x-axis go up by? 1, 2, 3, 4. So it goes up by 1 year. How much does each tick mark go up by on the y-axis? 50 million. What does the origin represent? It represents 2008 and 0 million posts. Okay, here we go over here. The United States Mint is responsible for producing and distributing circulating coins like quarter, nickel, dime, 50-cent piece, dollar, are used by people every day to buy and sell goods. Facilities in Denver and Philadelphia produce billions of coins each year. The table and graph show how many circulating coins were produced each year at these facilities from 2001 to 2011. Okay? What does the x-axis represent? Okay? So these are my x's, these are my y's. So year since, I should put years, since 2001. Then the y represents circulating. And yes, you should be putting this just like I am, coins produced. Now, I should have given myself more room. And that's what the y represents. How much does each tick mark represent? For the x-axis, 1. How much does each tick mark represent here? 2. 1 what? 1 year and 2 billion coins. What does the origin represent? The origin represents the year 2001 and 0 coins. Okay.